subject to where energy comes from. The three major fossil fuels, coal, oil and natural gas, are all formed from organic remains of prehistoric plants and animals. These remains are subject to intense pressure over millions of years, changing them into coal, oil and gas. We often find oil and natural gas in similar areas, hundreds of meters below the seabed, though gas is usually found deeper still. Through seismology, it's possible to artificially create vibrations on the surface by using controlled explosions, and record how these vibrations are reflected back to the surface, revealing the properties of the rock layers beneath. Wells are drilled from a drilling rig to confirm the presence and quantity of gas in the rock, which travels up lengths of pipe once reached. If there is enough gas, the drilling rig is replaced by a production platform to collect and send it to the shore under pressure via pipeline. National Grid then takes the gas from the shore and sends it around the countryside through steel pipelines over 1 meter wide. As the gas gets closer to homes, the pipelines split into smaller ones, which may only be 20 millimeters wide. How electricity is made. Atoms consist of a positively charged central nucleus and negatively charged electrons, which float around the outside in much the same way as satellites orbit the Earth. When groups of atoms form materials, such as metals, electrons are free to move and flow, jumping between the atoms. These materials are known as conductors. This movement or flow of electrons is what we know as electricity. Power stations work by turning mechanical energy, movement, into electrical energy. A mechanical force turns a turbine, which rotates large magnets within coils of wire, and this induces electrical current, generating electricity. Electricity generators can be powered in a number of ways. Burning fossil fuels. Coal, oil and natural gas are traditional fuels, but are harmful to the environment and cause climate change. Plutonium can be split to create nuclear energy. This method can produce huge amounts of electricity, but nuclear material is unstable and requires very careful management, and disposal of byproducts is difficult. Biomass is a renewable source of energy, including natural substances such as wood, organic waste, hydrogen gas and alcohol fuels. There are also other fuels which are renewable and are better for the environment. Wind power can harness the wind to turn the turbines and generate electricity. Hydropower uses the power and weight of water to turn the turbines. Solar power can also be used to generate electricity by capturing the sun's energy. National Grid can take the electricity generated from any of these sources, putting it into the network that eventually delivers electricity to homes and high streets around the country. National Grid plays a vital role in delivering gas and electricity to many millions of people across Great Britain and northeastern US in an efficient, reliable and safe manner. Electricity cannot be stored, so National Grid must balance supply and demand on a minute-by-minute basis. This function also ensures the security and quality of energy supply across the whole system, so that it's always there when it's needed.
Oil is a mixture of liquid hydrocarbons that are found in sedimentary rock, along with gaseous and solid hydrocarbons. That is to say, gas or bitumen, as well as other substances of fossil origin. All the molecules of hydrocarbons are made up of only two atoms, carbon and hydrogen. It is the quantity of carbon in the molecule that determines the state of the hydrocarbons. Gaseous, up to 4 atoms, liquid from 5 to 16, and solid more than 16. Hydrocarbons are a non-renewable energy source. and are formed over a very long period of time. The most favorable locations for the formation of hydrocarbons are places like the seabed, characterized by the continuous flow of detritus from rivers. Over millions of years, the accumulated rock, sand, and clay, mixed with animal and vegetable organisms and microorganisms, are compacted, forming the basis of sedimentary rock. The organic substances trapped in the rock, the so-called mother rock, are transformed at certain depths and under pressure and at high temperatures, first into kerogen and then into hydrocarbons. The whole process takes between 10 and 100 million years. Hydrocarbons that are lighter than water tend to rise upward and spread laterally through permeable rock. In some cases, they rise to the surface and disperse. In others, their rise is blocked by a layer of impermeable rock in the shape of a dome that traps them.
It takes a lot of energy to power our daily lives. Some of that energy is right here. Natural gas, locked deep in deposits across North America. Abundant, cleaner burning, affordable, an American resource that can invigorate our economy and help meet our energy needs for generations. Combining horizontal drilling with hydraulic fracturing has made recovery of shale resources possible and less expensive for producers and consumers. This advancement offers more production with fewer wells, substantially reducing our environmental footprint relative to traditional techniques. These proven methods occur deep underground. With responsible well construction and operation, extracting natural gas is safe and effective. At ConocoPhillips, we practice safety every step of the way. After months of well planning and geologic study of the subsurface, engineers select and construct a drill site based on topography. Next, a hole is drilled and a steel conductor casing is set to stabilize the ground at the top of the well. As drilling begins, a mixture, typically of fresh water and native clay called drilling mud, is pumped in. This cools the drill bit, removes cuttings, maintains proper pressure, and creates a boundary between the well and the rock formations. Drilling continues below the base of usable water to a depth specified by regulators based on local geology. The drill pipe is then removed, and more steel casing is inserted into the conductor casing. Cement is pumped into the casing, out the bottom, and back up to the surface, creating a sealed cement-reinforced container that extends from the surface to below underground sources of drinking water. This surface casing also serves as the foundation for the blowout preventer, a key safety device. To ensure a sufficient seal, the casing is pressure tested. Then drilling resumes down to the kickoff point, where a specialized drilling motor is attached, allowing us to drill the curve and horizontal sections of the well. Typically, we are thousands of feet below usable groundwater at a depth of approximately 10,000 to 13,000 feet, the equivalent of up to 9 Empire State Buildings. Multiple layers of impermeable rock separate the target formation from freshwater aquifers, preventing upward migration of natural gas and fracturing fluids into groundwater zones. Once the target is reached, the drilling assembly is removed and additional steel casing is inserted. More cement is pumped into the casing, out the bottom, and back up to a depth specified by regulators. This creates another cement-reinforced container for the collection of gas. With a perforating tool, holes are shot in the casing and into the shale at the desired location. The hydraulic fracturing process, safely used for more than 60 years in over 1 million wells, now begins. A fluid consisting of water, sand, and a small amount of chemicals is pressurized and injected into the well where it penetrates the shale, fracturing the rock. Many of the chemicals used in the hydraulic fracturing process are found in common household items and even food products. Sand or ceramic particles called proppant are carried by the fluid and deposited in the narrow gaps in the rock, propping open the fractures so gas can flow into the well. To isolate the fracture zones, a plug is set inside the casing behind the perforated section, and the process is repeated multiple times. The plugs are drilled out, allowing the gas and fluids to flow into the wellbore, where they can flow to the surface. The entire drilling and completion process generally takes only 2 to 3 months, compared to the 20 to 30-year productive life of a typical well. At the surface, the gas is separated from the fluids. The remaining water is diverted into storage tanks, and then typically transported for disposal in government-approved and regulated injection wells. With horizontal drilling, multiple wells can be drilled from the same pad site, optimizing production while minimizing the number of wells, roads, and other infrastructure necessary to recover this valuable resource. All operations are executed to meet or exceed regulatory requirements and protect our employees, contractors, the environment, and our local communities. As a leading natural gas producer, ConocoPhillips is committed to doing the right things, responsibly developing the energy resources to move forward.
So, these are the videos. That's it. Good day to all of you. Tomorrow we shall check with few more videos about the fractional distillation. Okay. Tomorrow I request you all of you to join by 9:30. Okay. Oh no, 10 o'clock, because I have the second period. By 10 I shall start taking the class. Please coordinate. See ya. Okay. Good day. Bye.